Hello and thank you for watching. In this video we're going to go through countability, sample spaces and events. Okay, so to start off, let's define what a countable set is. A set is countable if, okay, so it can be countable under multiple conditions. So it's countable if it's finite, which makes sense because we can count the elements. Or alternatively, it is countable if there exists a bijection to the natural numbers. Okay, if you've never seen bijection before, a bijection is just a mapping such that we can assign every element to another element uniquely. So for example, if we have the set 2, 4, 6 going to 3, 2, 1, we can form a bijection because we can have every element uniquely go to a different element, and we can also trace back the element we put in. Although, if we have something like 2, 4, 6 going into 4, 3, 2, 1, we cannot form a bijection because we will not be able to trace back everything uniquely. So for example, let's say we have this map here, this map here, this map here, then we see that nothing maps to our one, so this can't be a bijection. Also, if we have one thing mapped to two things, this also isn't mapping uniquely, so it can't be a bijection. Okay, so let's define what a sample space is. Sample space, this is the set of all outcomes such that only one can occur. Okay, so to give an example, let's consider a deck of cards, a deck of 52 cards. Our most obvious sample space is just having each card. So we have an ace of spades, we have a 2 of spades, we have a 3 of spades, and so on. We have every single card. But what if we're only concerned about the suit, for example? Then we can have a smaller sample space of, say, spades, of clubs, of hearts, and of diamonds. This is also a sample space because we're looking at a different thing. You can also have a sample space of, say, the values they take, the numbers. So we can have a sample space of just aces, 2s, 3s, and so on, right up to the king. Or we can even have a very small sample space. Say we're only interested if something is an ace or not. We can have a sample space of an ace, or I'll just write this one out. Ace, not ace. These are all sample spaces. We can denote it by different variables. We are going to denote it by capital Omega here. Okay. So now, notice how we have finitely many cases in each one. We have 52 cases here, we have 4 cases here, we have 13 cases here, we have 2 cases here. All of these have a finite number of cases, and so we call them either countable or discrete. And if we have an infinite number of cases that's not countable, then we will call this continuous. So for example, if we have the set of real numbers, so we have some sample space that uses the real numbers. This would be continuous because we can go as small as we want. This is an option, so is this, for example, and so we wouldn't be able to comprehend all the possibilities you have. Okay, now moving on to an event. So let's say A is an event. An event is just some outcome we can have from our sample space. So for example, if we went back, we can say, okay, let's say our sample space is 1, 2, 3, 4, and we're only interested in odd numbers, for example. So this event of odd numbers is just 1 and 3. This let's say we're only interested in even numbers, then this event is 2, 4. Let's say we're only interested in primes, this event is 2, 3, and so on. Now we have f. Our f, this f, this is the collection of, is the collection of all events. So if we say our sample space is discrete, then clearly we can just take f to be equal to our power set of the sample space, because this way we're including all the outcomes. So for example, say we had the set 1, 2, 3, and we wanted to look at every event individually. So for example, the event that we get a 1, the event that we get a 2, the event that we get a 3, the event that we get a 1 and 2 together, and so on, so on, so on. This is just a collection of all of our events. And that's precisely what an event is. Okay, and finally for this video, we're going to define what it means for two events to be disjoint. So I will rewrite that. Two events are disjoint if we have that some event A and some event B is equal to the empty set. So these can't occur at the same time. For example, let's say we had the event of, let's say we had a sample space of 1, 2, 3, 4 again, and let's say A was the event that we have odd numbers, is the event that we have odd numbers, and say B is the event that we have even numbers. Now a number cannot be even and odd at the same time, so clearly A and B are disjoint, so we say that A intersection B, or A and B, is the open set. That's all for this video. Thanks for watching. Hopefully this helped you understand sample spaces and events a little bit better. Thanks for watching. Bye bye.